Okay, happy Saturday, everybody. How are we all doing today? Hope we're all having a fun, fine Saturday. Okay. So, we're back on the simulator. So that's the project I've been working on. Um, for the past, I don't know how long has it been? This is probably it's a couple streams anyway. Probably the fourth or fifth or sixth stream, so 2 or 3 weeks of simulator so far. And I think we'll keep working on that. Let's see. So last week I spent a lot of time reteaching myself, basically. Reteaching myself how to do linear programming. Andrew, how you doing? Welcome to the stream. First time here. Yeah, thank you. Thanks for joining. So I've been working on a fantasy football package that basically runs season simulations, based on like it takes in like a player's ranking and then tries to generate like 1,000 weeks of what they could potentially score, and then basically we can analyze the distribution of those weeks. We can use that to generate projections of how teams work. So yeah, so that's basically my plan. And last week I was working on a way to determine the optimal lineups for each team, essentially. And I don't have a so I spent a lot of time on stream last Saturday and Sunday, and I took both streams to do it, to really kind of like wrap my head around linear programming again. So I should probably check out the version that I had at that point and kind of talk through what I ended up doing on Monday when I like threw it all out the window again. So I'm going to save this into a new script or so. And we'll call this FF optimize RGLPK, which is where I ended up. And we're gonna check out ref log. Simulations sound cool, yeah. That's sort of where I wanted to get to. Yeah, so I've been working on a bunch of different simulations and kind of simulating, trying to like take in, kind of keep one thing constant, and work through like a bunch of like dependent simulations. So like I'm taking a player's range of outcomes, based on like historical data, and basically you put in a rank for a player and then it's going to simulate everything forward. So that's the plan. And I want to load a previous version of the package just to compare, just to kind of talk through, because I did promise Afton, I think, when she was asking about this earlier, we were talking about me relearning how to do linear programming, because I didn't really remember. So I think it's this one. Head at 3. So git checkout head at 3. Nope. I think it's that one. Git stash. Git checkout. Yeah, I mean, I don't really remember it myself, so it's one of these like weird things where we're all kind of like it's all been a little while. So basically last time I was reteaching myself how to do optimal lineups, and what is going on here? Head 3 may have been too many. Main git checkout head 2. I think that's it. Yeah. Okay, so last week, basically, I spent a lot of time trying to figure out how to do linear programming because I wanted to take. I've basically like generated 1,000 or however many samples of however many like simulations for each player already, and that basically was done with a. Actually, there's a development file here that I should walk through, which will also help set up the example. Um, Yeah, so basically, I don't know how much you follow fantasy football or football at all, but we're kind of talking through stuff here. So let me pull up the example data, um, and basically, what is going on is I'm leveraging the work I've already done in this FF Scraper package, which connects to the API itself. Like the fantasy football API, so it ties directly to rosters. So basically, I take in like scoring history from 2016 to 2020. So pretty straightforward. Like Tom Brady had, in week 5 he had 36 points. In week 6 he had 33, 30, 23, 38, 10, etc. So this is like every player's every scoring history. And so basically, I mapped that to their preseason ranking. So if they were ranked quarterback 1, this is the set of outcomes for that player. And basically, I calculate how many games they would have played and how many games they may have missed on average, and then basically these are the players that make up that projection. So Newton was quarterback 1 at one point. Rodgers was it for 2 years, and then it was Mahomes, and then we've got a change in the guard, etc. So these make up the players, but really the key part here is this kind of population of outcomes. And what I'm going to do is to generate the simulations, I'm going to just draw from this with replacement however many times I need for every quarterback that's quarterback 4, and for every quarterback the quarterback 3, etc. So I'm going to redraw with replacement 1,000, 10,000 times, however many you want to run. I don't think it's necessary to run much more than 1,000. Like, I don't think you get tons more out of it, if that makes sense. But it kind of gives you a good sense of, okay, so you have the 12th best quarterback. There's a range that they could be anywhere from, they could at any given week they could score 6 or -6 all the way up to 49, right? Like the quarterback that you rank that high has quite a range of outcomes. So it's very possible, like, it could be whatever it is. And then there's also the probability that play the game, aka the probability to miss the game. And so I'm drawing from this basically like a binomial, randomly binomial with this probability. So basically just either ones or zeros, and then you would draw from this and say, okay, so if they did play, they would have scored this. This is the probability that they played, like the outcome that they played, and so you kind of simulate through. So, then I have a data frame of the latest rankings and rosters from a given league. This is one of my fantasy leagues. I'm Team Pikachu here. And you got lineup constraints. So basically, this is the part that I was working on last week, where I have to start at least, so I have to take at minimum 1 quarterback and maximum 1 quarterback. I need at least 1 running back and at most 6 running backs across all of them, and the same for running receivers and tight ends. And then I need a maximum of 9 offensive starters. So basically, I've just used this set of constraints, and there's other ways to do this, where you go, okay, so first you figure out, you hand solve for the minimum number of quarterbacks, running backs, receivers, and tight ends. Then you hand solve for the number of flex positions. So if there's 5 flex positions, you take 5 of the next best. So there's ways to hand solve it. For me, I don't like doing it that way because I want it to be able to handle weird scoring. So if you have a maximum of 3 running backs but 8 receivers, but it all has to fit under like 6 offensive starters or whatever, basically as long as it satisfies all the constraints, it's a classic constraint solving problem, which is great, and I know it's solvable, and I've only ever done it in Excel. So I spent a lot of time last week working through it, and kind of working through this projection. So you've got this projected score. So basically, I've generated the projection. however many times here, 100 times in this case. So for 100 weeks, and then basically I've got a projected score here for a single one. I think this is a couple. Hang on. N equals 001. N equals 1. And so basically, for the first simulation, there's this set of scores for this team, right? So basically what I was trying to do is figure out, okay, so how do I solve this set of outcomes into the best lineup for this team based on the constraints? So, okay, so, then I spent a lot of time refiguring it out, and basically, like, discovered this package called OMPR, which I would link if I was still using it, but I ended up dropping the function. But basically what it does is it passes in this, and it creates a matrix of franchise scores. I could pipe this over. Pikachu scores, franchise scores, pipe. I think it's there. Okay, so basically what the function does is it says, okay, so it makes a matrix of player IDs. So basically this is every player, and it makes a matrix of player scores, which is every position in their scores. And then it says, okay, so given that, here's a list of all the constraints. So it takes this lineup constraints table, and it tries to create so it says it creates a list of matrices. It creates a list of constraints. Constraints is now a list of 9, which is this list of constraints. And then it says, okay, so this is the way OMPR works: is you define this model with matrices, and then basically over this model you add an objective, and then you add constraints to it. And this made a lot of sense. As you may know, based on what I do in R4DS Slack, I gravitate to Tidyverse. So this seems very Tidyverse-like. And actually, I will bring up the page I was working on last time. And so basically, this helped me really wrap my head around linear programming again, and it took me a long time, but I did figure it out. Okay, so you've got, variable types, variable bounds, indexed variables. So basically I worked through this last week and got through, like, all 9 constraints. So there's the minimums for every position, the maximums for every position, and the total number of offensive starters. And then you solve this model, and then from there, I didn't set ROI engine, so ROI engine is going to be GLBK. And go. So basically it solves the model, and then it gets the solution, and you get this optimal lineup that looks like that, more or less, right? So then I return the list of optimal score and optimal lineup, and it works fine, right? Like, this seems to work. So then I was like, okay, so how does it work at scale? Because I want to simulate this for 1,000 weeks for 14 teams. So at least if I want to do 1,000 weeks for 14 teams, it's gonna be 14,000 simulations, right? So it is important to make sure it performs well. So what I wanted to do then is basically make sure that it operates at some speed, right? So you start with 100, and I was like, okay, so I've got parallelizing in my back pocket, things like that. But basically, we can use like microbench or we can use TikTok to time it, right? So TikTok tick dot ff optimize lineups. You got the franchise score, which is Pikachu score. Lineup constraints is lineup constraints, and ROI engine equals GLPK. TikTok. And basically, so if you run this, and you go, okay, so it takes 0.23 seconds to run on one, but if you kind of map this over, let's pick 10 because it ended up taking quite a bit. So let's say you map it over 10, there, and go. This takes map franchise scores, no, projected score, FF optimize lineups, lineup constraints is the same, so we can use lineup constraints here, and this, you know, for 10 total scores, select apply to class character. That's weird. Franchise scores. Bum, 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 bum. Okay, let's try that again. So let's try just loading it from the top. So, you know, if you run the whole thing, over this time, it's still broken. Why are you broken? Okay, we'll do on options, error equals recover, and try that part again. Oh wait, hang on, I need to nest. Okay, got it. So I'm gonna use this code here. Thank you for the follow, Cenobite Offsec. Welcome to the stream. Okay, so we're gonna use this. And basically the goal here is to optimize over that set of projected scores. So there's 10 times 14, so there should be 140 total weeks here. So this is 10 iterations because I changed it to 10, and you can see it's taking a good chunk of time. So we're kind of like saying, okay, so this is 10. I want to get to at least 1,000, and for people who are going crazy, I want to go through like 10,000 simulations. Like, you know, like I want it to be approachable to do 10,000 weeks. But for only 140 weeks, and 140 nests of data, basically, it took 28 seconds. So right off the bat, that's not great because you can throw paralyzing at it, but this is only 10 weeks of data. I wanted to get to a point, and I got to a point where it's like, okay, I should be able to do in 30 seconds. I should be able to do like 1,000 weeks of data, not 10, right? Like I want to do it, like I want it to be fast enough to do more than 10 weeks of data. So, you know, essentially you kind of look at every speed problem to start like reducing things. So right away you're looking at this chain of matrices. You know, I spent a lot of time refactoring it, and it ended up looking, so instead of feeding in matrices, I fed in vectors, and basically instead of that you get this score object here, which basically is just the projected score. So instead of making a matrix of projected score, I just made a vector of them, and then made constraint vectors, and basically just rewrote this whole thing so that I was feeding in directly to RGLPK instead of OMPR. And Pikachu score, franchise scores. So basically I was feeding in set of vectors, which you'll notice start populating down here, and a set of constraint directions and constraint matrices, and then basically just solving this lineup and returning the optimal there. And so basically, if you're comparing these two, it does operate quite a bit faster, and we can see that by comparing this function that we get out of it. So I named this function ffoptimize rglpk here. We're just kind of working through it manually. So actually I can just run this. And it should make... Wait. A function called ffoptimize rglpk, which is the current version of the function. And if we load and run everything up to here again, we can try to feed all the data into this, into like a comparable version, and kind of run the, we can duplicate and kind of compare these two times, right? So instead of ffoptimize lineups, you've got ffoptimize rglpk, and it basically works mostly the same. So basically, if you compare the two, so this will take at least 30 seconds, right? Because we knew it took 30 seconds the first time. So hopefully, if I haven't messed things up in how I'm feeding the data, we should see that it does a lot faster. And so it goes from 30 seconds for 10, hopefully, to shorter. We'll see exactly how much. It might prove me more or less than 100 times faster. But the more you reduce your problem down, the faster it goes. So yeah, so what took us 28.73 seconds the first time now takes 0.16 seconds, which is just, ridiculously faster. 28.73 divided by 0.16, you're looking at 180 times faster. So I was underselling it a little, I guess, but just like hard, like just stripping it out, right? And then if you compare the two, there's so much more overhead, and all this select, group by, mutate, pivot wider, as matrix stuff is so idiomatic for me that I didn't even think about it. But basically, as soon as you strip it out and it looks more like this, it's like, okay, well, wow, right? Like it's so much faster. You don't need to worry about making it a matrix. Just take a vector. And this whole control, like this whole variable piping thing that was here was really hard. So pipes are cool, but OMPR helped me really like learn it again. Is kind of the takeaway. But then when I like sat down, rewrote the whole thing, it now looks like that, and it operates 180 times faster. So much better. Tony, hey, I thought you weren't able to make it. Thanks for coming in. I haven't started yet. I was just recapping that I had a really frustrating time. Last weekend streams were really like crap, in that I really didn't remember linear programming, so it took me a long time to struggle through. Jesse, hello. You just have this on the background. Yeah, no worries. And it took me a long time to struggle through reteaching myself what linear programming was and how all these constraints and stuff worked. And that's where OMPR really helped me, because I was like, okay, so I can follow tutorials online about linear programming and translate it to code directly. But then as soon as you take, add constraints, set up vector, add variables, MIP model, then you solve the model, right? This is very tidy models kind of way to do it. But all of the linear programming stuff looks more like this. So, it took a long time for me to understand it, but then you kind of as soon as you kind of walk through that first process and work through the second process, it made a lot more sense. So, needless to say, I've sped it up significantly, so now I can run something in the order of at least 1,000, maybe 10,000 in the 30 seconds to 3 minutes acceptable simulation time. So yeah, so that's kind of a recap. I did this all on Monday because I was like, it really ground my gears as to how slow that whole thing was. And I pulled out future and map and parallel processing and fur and all kinds of fun stuff in the background. But it didn't really it took too long for my liking. And it can't take people that long to solve this kind of stuff. Otherwise, we'd never be anywhere. So I'm really glad that it worked out. And yeah. Okay, so I'm gonna close all that, and I'm gonna check out main. Get checkout dev. Get checkout. Is it dev branch? Main? Oh yeah, okay. So that looks right. Okay, so today, so now I basically have a way to like generate 1,000 rosters and a bunch of ideal like lineups and lineup scores. So what I want to do is kind of start thinking about, okay, so if I have a set of teams, and I will actually pull up my worksheet file again. Yeah. So okay, so let's say that we're going to go through 1,000 and map over 1,000. So what I want to do is so again, we'll run the TikTok on it just because we can. And this is over 1,000, so it took 9 seconds to map over 1,000, which is again significantly better than the 28 seconds that it took to do 140. So this is quite a bit better. So today's problem is we've got 14,000 observations of team scores. So, you know, anywhere from Simon Belmont's 721st iteration where they scored 35 points that week, all the way to Team Mewtwo's 283rd iteration where they scored 283 points, and everything in between in that 1,000-week period. What I want to do is say, okay, so it'll have to be 1,400 weeks and not 1,000. Actually, we should probably go ahead and do 1,300 weeks. We'll do 1,300, and this is kind of cooking the books a bit, but that's okay. Because there's 14 teams, so there's going to be 13 matchups 13 weeks of matchups. Because every team plays every other team, so it'll be 13 weeks of matchups. So that means you'll need 1,300 scores to do 100 seasons. So I'm kind of cooking this because I can do that math later, like in the main function. But today what I'm going to do is try to generate schedules so that you can like take all these teams and make them go head to head. And so that's going to be the goal for today. And kind of looking through past work I know about, is just always a good plan when you're tackling projects like this. And Tony, who's in stream, or in background in stream, is made a package called ffsked. Sked, I don't know, it's not whole words, which generates schedules. So I'm going to look at that to try to just understand what's going on there, and really to like think about, because I've got some ideas, because I've been marinating a thought about how I want to do schedules without coding, without actually writing any code for it yet, but I have an idea about how I would approach that problem. So I'm curious to compare A, the two approaches, B, how fast they are, because again, we're talking about speed here, and Tony's a very efficient programmer, so hopefully I can, get close to that in my own attempts to generate schedules, and if not, understand how to incorporate that into this package, probably just wholesale ripping the code if I need to, crediting Tony as an author and dragging it to Cran because that's just the way we're gonna roll it. So if I end up using Tony's schedule, which is very, very possible, I will make Tony a Cran author, like not just a contributor. We're going full on authorship here. So, okay. So we're gonna clone this and install it. I could have done that from pack, I guess, but just take Tony's word for it. Color space and dplyr. Color space. Did you include plotting for your own? Okay, all right. We'll keep the old versions because I don't think it matters to go from point 1 to point 2. Okay, so we got Tony's package and reading the docs because reading the docs. Basic usage. Okay, so Tony generates. So Tony was talking to me about his approach before this, and basically he's trying to simulate 1,000. His primary goal was to make sure that none of the schedules were ever overlapping. So they were all. He wanted to make sure, like, completely 100% that however many he generated, he wanted to make sure that it never generated the same schedule twice. So, which is very, very possible. Don't get me wrong. Like, I think that makes a lot of sense. I have ideas about how to do that as well. But I'm just gonna kind of run a benchmark time on Tony's schedule sim and just understand how it works is kind of my goal. I remember Tony brought up this printing error in his package down, and I don't understand what it's about, but we can deal with that later. Standing sims wraps the stuff above, make an interesting plot. Okay, so the motivation behind his schedule function is to generate as many unique schedules as possible. The goal behind the package is to take a known set of scores and then kind of control for the variation in scheduling. So basically, generate 100,000 different schedules and figure out like what percentage of how much effect that schedule had on where each person finished. So, you know, going back to his basic usage reference here, you know, the Team 05 finished in what was their 19.8th percentile. And some teams like Team 07 finished with like in a 1.1 percentile outcome or percentage odds outcome. So they were supposed to be first, but they ended up being 7th, which is quite a fall, if I say so myself. So based on 1,000 unique schedules, you're seeing that, you know, Team 05 was supposed to finish second, but they finished first. So the team that was supposed to finish third finished second, and the team that's supposed to finish first finished 7th. And I have a feeling, Tony can probably confirm this if he was listening. He may not be listening, but I have a feeling that this is Tony, and the whole reason this package exists is because he finished in like a 1.1 percentile outcome. and so that's why this whole package exists. So there's obviously random variation that goes on here, right? Like, you know, this team finishes anywhere from here to here, but they finished relatively high. This team finished relatively low, and so basically just the way luck fell, this team ended up in the second least likely possible outcome, which is like a 1% chance. So crazy, right? Like, you know, but that's how fantasy football can work sometimes, and same with life, right? Like, you know, it's crazy. So we'll generate some schedules, and I just want to kind of see how long it takes to generate them. So ffsked library ffsked And this is generate schedules. League size is we'll say 14. Weeks is gonna be 13. Sims is gonna be let's say 100. Because we're just gonna map it to this n weeks afterwards, so we'll get there eventually. What is export? Export Parquet. Hey, Parquet, I like it. So I guess Tony writes these to a file. I don't want that, so export equals false. Check duplicates. So I'm going to leave the check for duplicates just because I think I also want unique schedules if possible. And how many times to retry? So tries, I'll just leave the tries as default. Yeah, use a brute force approach. Okay, so weeks greater than league size is not true. What? How many weeks are in the schedule? Presently, this function requires a league size is less than or equal to league size 2 times league size times 1. Presently, this function requires that league size is less than league size, less than or equal to league size. Okay, so that's probably just error. League size requires that weeks greater than what? League size minus 1, so that's 13. So 2 times 13 is 26, which is 14 weeks? 13 weeks? Nody, are you still watching? We're gonna figure out what this is. Okay. Stop if not weeks greater than league size. It's not. Why would it be though? Wait, what? Why would league size be greater than the number of weeks? Or less than the number of weeks? Phil, welcome back. How are you doing? Okay. So I don't get it, but I will begrudgingly bump weeks to 14. You're in the middle of your first Dynasty startup of the year. Awesome. How's it going? How many rounds are you down? What's your team like so far? Okay, so at try I equals 1, 4 tries, 3 tries, 2 tries, 1 try, 0 tries, stopping early due to reaching number of tries, converting individual schedulings, error name must be null or a character the same length as X. You got Kittle, Waller, and Lance. Tight end premium, I'm assuming? Options, error equals recover. It's a safe league. Okay, cool. So 2.0 tight end premium. Neat. Sorry, one sec. 4, 5, 3, error name equals set name permutate. Let's go with 7. Eric, how are we doing? Welcome back. Nope. We are going to find... I think it's one. Or mid debug, yeah. That's a pretty tight end heavy start you've got going there. I like it. It's a little old, but not bad. Okay, so this is the main function here. Steve vacuuming, what a chore. Yeah, it is. Oh man. Okay, so while this, where's set names? Okay, so set names is here. Did that go? Hello? Res mats? Okay, so at least, so we got 100 schedules. I think it's fine. So basically I want to R-bind them. Argument 1 must have names. The schedules, yeah, that's what I'm working on. Sorry, yeah. So I'm working through Tony's package and trying to see how much I can steal, reuse, copy, and B, just understand how well it does. It seems to work very fast. It hit an error pretty quickly, so that means it got through like the bulk of the heavy lifting. I think this is just cleanup. Sprint F, week 1 to 9. Does that make names going horizontally? Res mats. Okay, so it's a matrix. So I want to map it as a tibble and then set names? Is that that's what's happening? I think so. Okay. And I think that's what Tony's getting at too. So, okay, so the problem is that the set names is 1 to 9. Tibble, yeah, so that's a data frame. Tibbles are, I think it comes from letters TBL, DF, which is what was used inside of, like, that's like a table data frame. And then somebody at Tidyverse, started calling it Tibbles. So, yeah, it's an R thing. Apparently it wasn't named after the cat in New Zealand. There's a famous cat named Tibbles in New Zealand, which I thought was the reason why it was called that. It's not. It just happens to be the internal shorthand that became external. Okay, so I think the reason why this is because he's hard coding names 1 to 9. Um, going horizontally, which seems interesting. Because there's now 13, right? So, if I did sources not available, I can't actually edit this, which is a little annoying. Well, I can run it though. So we got 13 weeks by my thing. So we've got res wide is now 1300 rows across that with an index of sims. Okay. So yeah, so I think I want to roll. There's probably something to be done with this, but I don't. Weeks extra, return res tidy, adding extra weeks by copying the first n weeks, which is cool. Yeah, so this is exactly what I was gonna do. By copying the first extra weeks. I was actually gonna do the same thing, which is cool. Yeah, okay, so I think I'm gonna try to roll my own schedule function. Mostly because I don't understand it enough to debug live on stream. And I don't think Tony was planning to take his package to CRAN, so if I want to take mine to CRAN, I do have to maintain both sets of code. So I do actually want to take this to CRAN. It's kind of one of my little goals for this project. So I will probably start writing my own. And if Tony wants to, if you know, we want to kind of work through how well mine works and, you know, any features that Tony wanted, I will probably come back and steal stuff. This seems not tan-like, if I may say something about while, if, else. That's not a very me thing to do. I kind of avoid that. So, okay. So I will get rolling. I will try to roll a schedule. I think that's where I want to go with this. But this is exactly where I want to get to, which is this team 1 plays Team 1 plays 2, 9, 5, 8, 4, 11, 13, 12, 10, 6, 14, 3, 7. And I want to just roll through that for every single team. For every single team, every single week, 100 times. So I think that's very close to the same thing, but I have slightly different implementation plans. So this may be interesting to kind of compare approaches. So, okay, so we are going to write this function from, we'll call it scratch. Yeah. Well, okay. Okay, so how am I gonna do this? So, this will probably be its own thing. Whoa. Rebuilding the package, okay, that's doable. So what I want to do is I'm gonna start a new thing called ffschedule.r. It may get renamed several times in the process, but the idea here is to generate n number of schedules. So copy the function bodies. So this one's generate fantasy schedules. So the number of seasons to simulate, that's fine. The weeks per season, I think, is also fine to stay. Not best ball. Seed matters or doesn't matter? Seed, I'll leave seed in there. Injury model doesn't matter. Owner, verbose. I didn't end up using verbose in the other thing anyway. And this is going to be exported. Yeah, I think exported. Because it may be useful elsewhere. Okay, so ffsimulate. So this is going to be ff schedule. No, sorry, I already have ff schedule in ff scraper, so I want to call this something like build schedule. And really what this is going to do is just generate a bunch of random schedules with n seasons, weeks per season, seed equals null. If not null, seed, we're going to set seed to seed. Okay. Actually, hang on. Why was null? Okay, so set seed doesn't get the current seed. Get seed. Seed. What is get seed? Dot random seed. Whoa. Random seed. Okay. I think this is the next set of seeds. I think. I think that's okay. Okay, so if seed is not null, set seed. There's no way I'm gonna be able to re-put the seed back. So that's, I'm okay with that. Okay, so Alright, so we're kind of laying out the way this is going to work, and the way this is going to work is I'm going to generate the round robin schedule template, and basically there's a few like round robin schedule Wikipedia. So there's a few algorithms for doing this. One of which is this circle method, which is fairly common if you're kind of visualizing a chess tournament and really any head-to-head tournament, any head-to-head table. The way a round robin tournament works is every competitor is assigned to a number, and then they're paired in the first round. So 1 through 7, then 14 through 8. Next, one of the competitors is fixed, and then everybody else rotates clockwise one position. So 1 stays in this corner, and then 14 goes from here to there. So basically they move from here to here. And then everybody goes this way. 8 goes over there. 7 goes across. So 6 plays 7, etc. So basically the circle method generates a concise-ish way of making sure that everybody plays everybody across a given week. And so basically my plan is to generate the round robin schedule template for the number of teams. Actually, that's an important one I don't have yet. And teams. And that's actually going to come here-ish. End teams, end seasons, weeks per season. And those are important things here. And teams, number of teams in simulation is 12. What is this? We'll just roll with it. Okay. We'll go with 14 because that's where that's the example here. So empty out this console. Don't know why it's still there after I restarted. End teams is equal to 14. End seasons is going to be equal to 100. And weeks per season is going to be 13. So that's the bare minimum. And so basically there's kind of steps to this, right? And then basically I'm going to try to do randomized. I'm going to try to draw from the random list of teams. So basically once I have a template, I'll have like the correct team on the top, like going like along one side, and then the team that they play. And what I think I can do is pivot that so that it's team and then their opponent. And then basically what I'll do is generate a random order to assign each team to that. And then I'll also randomize the number of weeks that they play. So like which week is in which order. So in order to generate like random, so basically you have like a sequence. In this case, if you're going for 13 weeks, you'll have a sequence from 1 to 13. I'm going to draw from that randomly 100 times, and I'll also draw the order from, so basically I'll like map. So what I want to do is like randomize team order, and then randomize week order. And so team order is going to be something like let's say that it's 1 to 14 is the end teams, is the teams. This is really annoying actually. I might like close and then restart R, because this environment's not working. Hello. Okay, so you got teams, and so basically if I want to draw 100, I want to reorder these teams 100 times. Generate order. I think I want to sample. Teams of size 14. And that should generate the number of things I want, which makes sense. So basically this will like draw out a bunch of different orders of teams, so that'll be that'll randomize which team is in which order. And then what I want to do after that is generate a random sample of which weeks are drawn. So week So weeks can be done with the same thing. Weeks, if weeks is 1 to 13, for example, then sample of weeks for length 13 will reorder my weeks. Right? That looks right. Weeks. Yeah, okay. Yeah, so that's how I plan to randomize the week order. And then basically if I generate permutations of week and teams, and then use that to do joins to fill in the team and the opponent, that will generate randomization of that, and hopefully none of them will be distinct. 5 extra 2022 first. Okay, now I'm impressed. Sorry, I just noticed that in chat. Well done. Yeah. So, okay. Ooh. Okay. So, on the clock trying to get one more. Yeah, well done. Okay. Weeks 1 to 14, and then basically I just need to draw this 100 times. So sample, so I want to do map 1 to 100, right? Yeah. Okay, so I just wrote the code for this already. So sample weeks is going to be seek length weeks per season. Okay, hang on. So you're going to write randomize team order n for length of n seasons, and then you're going to do the same thing with randomizing the team order. Randomize team order for length and seasons, and then hopefully there will be no duplicates if you do this however many times. That's the goal. So let's see. Map seek length and seasons. Sample seasons teams. So seek length of n teams. We're going to sample teams. We're going to sample teams a length of length and teams. Wait a second. Nope. There's more to this. Hang on. Nope, hang on. So that's okay. So, we're going to sample teams the length of n teams. Or, so that's just n teams, rather. And that's going to be a per map. N seasons not found. So n seasons is going to be 100. Weeks per season is going to be 13. And n teams is going to be 14. So if that's the case, actually I want to do 14 here for a couple reasons, but I'll get there in a second. Okay, so you got teams, you got team orders. It's going to be a list of 100 integer lists. So that's okay. And basically it has a bunch of different orders, and I think it can run unique on this. Can I run unique? Team orders unique. Length. Yeah, so this generates relatively unique, which makes sense. I think it's close to unique. I think it might be close enough that Tony doesn't. Actually, hang on. How long would it take to do 1,000? So team orders. Let's say end seasons was 1,000. If we did that, it takes almost no time. And then it's still unique. And that makes sense because that's 14 factorial is... What is 14 factorial? 14 factorial is a lot. Okay, yeah. So, very big. Okay, so we'll do the same thing for weeks. But weeks is going to be slightly different because we're going to need to generate... Nope, never mind. Weeks is going to be the same. So weeks is going to be seek length of weeks. I actually don't even need... I don't think it even matters. It may not matter. Yeah, it may not matter. Okay. Yeah, it doesn't matter. Okay. So I'm gonna... I don't think I'm gonna reuse this, so I'm gonna go... there, and then if I need it again later, I will. So I'll do the sequence then. So week orders is going to be the sample weeks, which is going to be seek length of n weeks times something like that. Team orders, week orders. So n weeks not found. Go n weeks here. Keep it relatively consistent. N weeks. Okay, so those were the easy-ish parts. And it takes like nearly no time, which is good. Okay. So once you generate the round robin schedule template, which is probably the part that I'm going to do next, and then we'll join 4, makes it a nice little section. This section is going to be join team onto week onto join team and team ID and week ID onto the template, or the reverse, maybe the reverse. Join template. Join template onto team and week. So if we're gonna do that, we can actually start writing the bones for that, which will look like team orders. So it'll be tidyr crossing. No, it won't be crossing. It will just be tibble with team ID equals team orders, week ID equals week orders, and we're gonna pipe it and unnest longer. It's gonna bother me. ID, week ID. We're gonna unnest longer the team ID and week ID. So see team unnests both team ID, week ID. See this and this. Okay, so that generates 14,000, which is not what I wanted, actually. No, that's not what I wanted. So maybe I did want crossing? Did I want crossing? And season. Week ID equals still week orders, but I'm going to unnest that afterwards. So tidyr unnest week ID. I think that's what I want. Nope, that's not what I want either. Okay, I'll solve this problem later. I think that's a problem just for later. Okay, so now I'm going to work on this, So now I'm going to work on this round robin schedule template function. And it probably is a... So... I could generate each time, and we'll see how long it takes to generate, but the other option for a schedule template function is just actually making a data frame of this template. And the reason why you could do that is because your schedule would then... like your schedule, like there's a fixed number of teams, right? The only thing that comes into this function is the number of teams. So I could probably pre-calculate all the common ones and then check to see if it's there. That may be where I go with it. I think that's where I go with it eventually, but I want to write a function to write it first. So let's go get and build circle, and 2022 first is quite impressive, good sir. I am impressed. It's well done. Build round robin, and that's gonna be end teams, and that's just gonna get the right template. So template 7 of 12. Good grief, that's gonna be fun. I'm impressed. Okay, so build round robin for end teams. So schedule template. Okay, so round robin, and actually I could probably do the end. Wait, no, I'll do it on weeks after. It'll be a second function called check. Actually, so we'll do round robin build. And then we'll call this FF round robin. So round robin build, and then we'll do round robin. Expand, contract, size, trim, size up, and that'll be n weeks. Okay. Sizing. Size. Good enough. Okay. So what we're going to do is write a function to generate that table of weeks, and then we'll duplicate the vector, the number of elements, so that the length is correct. And then we can pivot it longer. And then we can memorize some of these, possibly. Memorize, something like that. We'll memorize some of these. Probably the round robin build part. That may be the slowest part. So let's look at that. Okay, so internal keywords, internal ff round robin build is going to be a function that takes in n teams, and basically n teams is going to be so we're going to take the vector that is seek length n teams. So that's every team. So we'll call this all teams. And then the way this is going to work is all teams and what am I listening to? This is kind of weird. Oh well, we'll just leave it. That's good enough. Okay, so all teams, I'm going to take n teams, default 100. Okay, so let's go back to the 100. We can do 1,000 later and kind of compare the speed, but we'll do 100 first. And basically the goal here is to take half the vectors. Half one is going to be n teams. Wait a second. Okay, so I need to check if n teams 2 then We will skip that. Okay. End teams. So basically what I'm thinking here is to build this, I need to figure out what happens if a team is on bye. And basically what I would do is replace... Would I, like, do an extra table? So, it's very rare that there are odd-numbered fantasy leagues, but it is possible. So I should figure out how to handle it. And I think the normal way to handle it is that somebody's on bye. So I need to figure out how to add a bye team. And I think end teams needs to be think about that for a second, because I need it to generate the schedule. End teams, if we'll set bye equals null. Then if n teams 2, then bye equals true, and so we'll set bye to be true, and we'll also add 1 to n teams. So n teams, it's equal to n teams plus 1, and then we'll just have to remember to handle that. So we got bye is false, and we've got n teams still at 14. So then you got all teams here, and that's just basically sequence of length n teams. And then we're gonna take the first half, the second half, smash it together, line it up. So half 1 is gonna be equal to all teams, head all teams, n teams divided by 2, half 2 is going to be equal to head all teams, actually it's going to be tail all teams, n teams divided by 2.
After successfully linking Elliot's brain to the cybernetic matrix, Steele puts him into a calming dream state. But as Elliot's subconscious awakens, he begins to experience dreams that the human brain was not created for.
Okay, so 1 faces 8, 2 faces 9, 3 faces 10, 11, 12, 13, 14, and basically just continue onward. Actually, I could reverse it so that it is a bit more of a traditional one. There. That makes sense. Okay. And then basically, for each element in half 1, I need to figure out how to store the matchup. So, week 1, weeks. Weeks is going to be a list. It's going to be a matrix, isn't it? Can it be a named matrix? It might be better if it was a... It would be better if it was a... list. And it's going to be a list of lists. Yeah. Okay, so this is going to be the schedule. And it's going to be a list. And then we're going to seed the list with week 1, which is going to be half C, half 1, half 2. How do I set a list of a length again? Set list length R. Ah, vector. Okay, so we're going to have a list of length n teams minus 1. And that's so every player goes through the cycle once, which makes sense. And then half week 1 is going to be schedule 1 is going to be half 1, half 2 combined. So that just puts them in order. But we're going to set names so that it is set names C half 2 half 1. I think that does what I want, which is 14 plays 1, 13 plays 2, 12 3, etc. So okay, so that's going to be the first element. Number of, and this is going to be a list of C, that. There. Must be the same length as the vector. Okay, hang on, so let's rerun this. Warning message, number of non-multiple of replacement length. I'm okay with that, I think. We'll call this week 1 anyway. That might be the better way to do this. So, week 1. It is still a little annoying, but maybe I want 2. Ah, okay, perfect. Okay, so bum 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 bum. For which is again not very me-like, but we'll just roll with it. Weak in and in length. Joe, I was hoping you wouldn't see this. Sorry, buddy. And I'm like, this is kind of like on par with the like discovery that this is slower. Your for loop sensors are tingling. Did you just join to see this? This is like being caught with your hand in the cookie jar. A few minutes back. Nice. Your for loop sensors are tingling. Okay. So for week in seek length, end teams -1. -2. No. We're gonna go 2 to end teams. 2 to end teams -1. And so basically, because we did week 1 already, and we did that by hand, what we're gonna do is take half 1, truncate. I'm gonna run this circle method. So we'll take the half 1 that's there, and we're gonna move the head of half 2 to the head of half 1. Half wait. Half 1 is gonna be you move 14 over, so it's tail half 1 -1 removes the first element, and we're gonna add 14 to it. So C tail half 1, head half 2, 1. So that's the new half 1. And that's crap. That's not quite right. Because now it's 2, 3, 4, and 14's at the end when you want them at the beginning. So now you're going to do that. And I need to reset this. So we'll go with head half 2, tail half 1, which will make a new half 1. I'm just watching it change here. And then half 2 is going to be C, and we're going to remove the at the last. No, we're going to remove the head of half 2. So head half 2. No, it's the same as the other one. So tail half 2, 1. One, 2, 3, 4, 5, 6, 7. Is it just 8? Should 14 be the second position of the new half 1? Yes, good point. So 14 should be the second position, so it's always going to be 1 head. And I can trim off the last one here very shortly, but I want to refer to it. So we're going to do tail half 2 -1 and tail half 1, 1 will give us our new half 2. 1, 2, 3, 4, 5, 6, 7. Then you gotta remove this last bit of half 1. Right? Yeah. Tail. No. Head. Half 1 minus 1. That'll trim off this last bit. And then we can do schedule week here, and it's going to be C half 1 half 2. We're going to pipe it to set names C half 2 half 1. Week not found. Okay, so assuming that we didn't mess it up, we will we'll use I, because that's a little more traditional here. And assuming we didn't mess it up, it has not been very helpful. Okay, so n equals 14. Okay. Bing. Could not find function pipe. It's useful. Okay, so our schedule vector has a bunch of named integers, which is cool. And what I'm going to do is take our schedule, we're going to deframe it. Tibble deframe end frame. Name value. Is that what I wanted? Maybe. Wait. Let me think about what I wanted. Okay, hang on. So I'm currently being distracted by the fact that I ended up with all doubles except the first one, and I think it's because of this integer that I'm looping in here. So we will try that again. Yep, now we got integers, which is good. Okay, and then the second thing is I want to end frame not. I want to map the end frame. That's what I want. Per map end frame, which makes a bunch of tibbles with names and values. Name and frame, tibble and frame. Name's going to be equal to team, value equals opponent. Name equals team, value equals opponent. Okay, so we got this. So you got a list of tibbles, and then what I want to do is find rows. Week is going to be equal to row number. think. And actually I can do just seek length of n teams here, I guess. Teams -1. Wait, it found rows funny. Map. And then we're gonna go Tibble, Tibble. And we need n teams -1 here. Bing. Okay, so we got week, we got the first thing. So then we're gonna unnest. Tplier, unnest. No, that's a tidyr thing, isn't it? Tidyr, unnest 1, and that'll give us our schedule. So on week 1, team 14 plays team 1, 13 plays 2, 12 plays 3, 11 plays 4, 10 plays 5, etc. all the way through. And actually, it would be more. I should switch the opponent and the team here. And Eric is hosting my stream. Cool. I think that just means someone clicked on our podcast. Okay, so now I have. I'm going to switch the opponent and the week, and the reason I'm going to do that is because that way I don't have to. I can be lazy about sorting. Maybe? I don't think it matters, actually. So, and then, I'm going to, let me think about this. I want to convert them all to integers, so I'm going to make dplier, mutate, team equals as integer, data team. Okay. And we're going to arrange by it. Week. We're going to transmute actually because I decided that might be more fun. Opponent. Data.week, data.opponent, and we're going to arrange by week and team. Actually, it needs to be data.week, data, and data. Okay, so that's our mapping of week, team to opponent, and this is kind of like the base schedule. So what my plan is to basically join on 100 times the new week identifier and the new team and opponent identifier based on this schedule, and I'll do that 100 times. So wait, thinking. Is this the most efficient way to do it? I think it is. I had a stray thought that I lost track of already. Oh, the buy thing. Okay, so if buy equals true, if buy, then X is going to be df schedule. Then we're going to change df schedule so that dplier mutate at C team and opponent. Turn the music back up a little. Okay. And we're going to replace we're going to replace 14 or whatever 15 it would be with NA. And so basically, if there's an odd number of teams, we're going to replace that so that there's a bye, and the bye is going to be NA. I think that makes sense. Because if there's 15 teams, then you can't have a game every time. So let's say it's going to be, let's say for some reason that there's a league out there that has 15 teams, could be a Scott Fishbowl thing, and you wanted to still do a head-to-head schedule. What you would do is take your 14, you take the opponent, and yeah, so you take the opponent that is 14, so dplyr case when .x equals n teams, and we'll replace it with NA integer. True is data, true is .x. And basically that just blanks out all the teams and opponents where weak is integer, and then dplyr filter is NA data team. And basically then it removes bi-week's set of games. Yep, that makes sense to me. Okay. And then return df schedule. So now, oh, I didn't mean to do that. I'm really annoyed by this RStudio thing not clearing my... It's not clearing my workspace properly. Why don't you clear my workspace? Never. Yes. Yes. Advanced. Yes. Okay. Alright, so I'm just gonna leave that. Yeah, so there's nothing in my workspace, so this is just probably a visual bug. But I should be able to run this FF round robin build. Give me a schedule for 12 teams. Generates 122 games. Which is 11 weeks long. So basically what this is doing is it says, okay, so generate this however many times, which is cool. And what it's going to do then is, okay, cool. So then that does the first part, which is builds the template. And then I want to generate the round robin size with the number of weeks. So this is going to be a second function that takes the schedule and tries to coerce it to be the right length. So what it's going to do is say, okay, so what it's going to do is say that schedule and weeks, so it's going to do if max schedule week is equal to n weeks, then return schedule. So basically just exit early if the schedule just works. And it's helpful to just kind of make sure that this name lines up with this name, because I can just run this internal function and then it'll always build the right thing if I wanted it to. So I'm going to go with that. DF schedule, max of that week is n weeks, return that, otherwise do stuff. So let's say you have a 12-team season, a 12-team league, DF schedule, and I wanted a 14-week schedule. So n weeks equals 14. I'm switching here because I want it to be bigger, and I'm having trouble conceptually visualizing larger seasons. So okay, so let's say 14, and I'm going to take 14. So basically this is if max DF schedule week, and actually I should probably save this as a variable because it's going to be useful. Schedule max there, so we can just reference it rather than recalculating this max every time. So schedule max is equal to that, then good. Schedule max is less than n weeks. Return so if schedule max is less than n weeks, which is this is the case, what we're gonna do is take the first n weeks. So df schedule filter, not that filter, this filter. Filter the week less than or equal to schedule max minus, no, n weeks minus schedule max. Okay, good. And then bind rows to df schedule again. No, wait, I need to set the right weeks first. So it'll be dplyr mutate week equals week plus schedule max, and then dplyr bind rows back onto schedule max. No, bind rows of ds schedule, and we'll arrange week. Perfect. So basically it'll just duplicate the first 3 weeks, since there's only 11 weeks in a 12 team schedule. So it will duplicate 12, 13, and 14. And I can skip the arrange if we bind in the other orders. So df schedule is going to be equal to bind rows df schedule and x. Good enough. We'll throw in a spare variable. It'll get deleted shortly after this. Okay. And then the other way is if you have fewer weeks than you have is if you have fewer weeks than you have teams or in the schedule already. And the easy way to do this is to check if schedule max is greater than n weeks, then keep weeks No, I'll just drop the last three. Okay, I think that makes let me think about this. So, if there's 16 teams and there's only a 13-week schedule, I could drop the unnecessary parts of the schedule here. If I do that, then if I do that, it will bias the simulation a little bit, because whichever ones I drop will...
We can't save him. I can't save him.
Whoa.
He was my son.
We're gonna move on to just pure music here. It'll bias the simulation a little bit, because you won't play 3 teams. But it'll be a different 3 teams because I'm randomizing over the course of however many weeks, so it's okay. Alright, so I'm just going to trim off the last 3. So df schedule's going to be equal to df schedule dplyr filter week less than or equal to n weeks. Okay, so I'm just going to trim it off, and the reason why I'm going to trim it off is because I'm reshuffling the team order every single time, so it doesn't really matter. It's still going to be an unbiased sample in your simulation. So, okay, I'm with that. So we've built the schedule, we built the size. Okay. So if I load this, my schedule template will look like... will break because I didn't set the default arguments. Okay, so I've got a schedule template. It's 196 long, and it takes... I didn't run TikToks, but I'd like to. TikTok, tick. TikTok, talk. 0.02 seconds elapsed. Okay, so that's nothing. And what I want to do is make a tibble with team orders equals team orders, week orders equals week orders, and schedule template equals schedule rep no list schedule template. Does that work? Team orders not found. And seasons not found. Let's say 100 seasons. Let's say 10 seasons. It'll be easier to look at. Okay, that is negligible fast, which is good. And okay, not bad. So now if I unnest schedule template, no, I don't want to unnest schedule template yet. What I think I'm going to do is I'm going to write a function to apply schedule template. Apply template, which is a function that takes the team order, week order, and the schedule template. And we're going to take the first team order as team order. And week order is going to be equal to week orders 1. And schedule template I think already exists correctly. It does. Good. So we're going to take schedule template, mutate team order. No, wait. Team order is going to be equal to I'll borrow Tony's trick here, I think. I learned this from Tony when he was doing the ESPN methods, and I really like it actually. So what we're gonna do is take schedule template, we'll dplyr, mutate. Team is going to be equal to team order, but I'm going to use the square bracket to index with the team. And what that's going to do, hopefully, is just index over actual team to get what actual team 1 is and actual team. So basically, because I have team 1 is 8, team 2 is 9, team 3 is 12, etc., I can use a square bracket to get the right team. So we'll go team there, and we'll go opponent equals team order data opponent. And what that's going to do is just reshuffle. So let's just check briefly. 8 plays 1, and then view. So 8 plays 1, and 1 plays 8, which is good. 9 plays 13, and 13 plays 9, etc. Perfect. Okay. And then what we're going to do is also do that for week. So week equals week order data week. And so basically it reshuffles the order that the weeks also appear in. So hopefully that the schedule continues to be unique. And then we will arrange. Actually, I'll try to arrange it. Should I arrange it after? Yeah. Yes. No, I'll arrange it now. If we need to, we can arrange it later, but I'll try to arrange it first. So we'll arrange by data week, data team, data schedule, and we'll return data schedule. Okay, perfect. So then I'm going to map, deploy, mutate. I'm actually gonna do per map 2. Team orders, week orders, and schedule template. Can't convert to a function because I didn't put a function in, so the function is ff round robin apply template. Okay. That happened quickly. Does it happen quickly for 100? Let's find out. Yep. Good enough. Negligibly fast. And we will then schedules. It's gonna be Tibble. Actually, let's try crossing. TidyR, crossing, season equals seek length and seasons. Go. 10,000 of 2 variables. That's not good. I only needed 100. So I actually don't want crossing here. I want Tibble. So make it a Tibble. We then dplyr mutate season equals seek length seasons, and then we will tidyr unnest 1. Boom. 196 times 100 seasons gives you this, mostly. Let me see if I can make it faster. Not faster, but if I get in the order I want, without needing to do it this way. So I'm going to put it here and hope that this works. Schedule is going to be equal to this. Yep, good. So X there. Whoa. I there pipe tidyr unnest schedule and go. Season, week, team, opponent. Okay, so basically this generates a whole bunch of random schedules where 5 plays 1 here, 2 plays 11, 3 plays 13, 4 plays 14, etc. It takes not very long, hopefully. So that builds schedules, which is good. And return schedules. I think that's it. Okay, so if I wanted to generate a schedules for FF build schedules. And I loaded that, which is bad. Let's load that again. FF build schedules for 14 teams, 1,000. Let's go bench. Let's go TikTok. Okay, we'll go with TikTok. So in my worksheet, if I have these optimal scores, multi-session not found, that's fine. Okay. So now I want to figure out how long it takes for me to generate these schedules, and I'm saying 1,300 weeks, which means I want to do 100 schedules of 13 weeks. Got it. So FF build schedules. We're on a TikTok, so tick, TikTok, tick, TikTok, talk. That took 11 seconds to calculate the optimal scores, which makes sense. I think that's a harder problem to solve. FF build schedule. So N teams is going to be 14. N teams is equal to 14. N seasons is equal to 100. N weeks is equal to 13. Seed, I don't care. Schedules. Okay, so build the schedule. Oh, that disappeared. 0.34 seconds. All right, so it doesn't matter how long it takes. Not how long it takes. It does matter how long it takes. It doesn't matter how many iterations you want to do. 0.34 seconds is nothing. Perfect. So, okay. So I guess it's already 10 o'clock. Wow. Time flies when you're having fun / solving problems / whatever. Okay, so now I can join my optimal scores onto the schedules. So I have a large data frame of schedules, and I just need to figure out what team is 1 through 14 and what team. So I'll just use the franchise IDs. In MFL, that's really easy. In other leagues, it may not be as easy, so I'll need to figure out how to handle that join later. But for now, what I can do is take my optimal scores, which I have 1,802, 18,200 of, and I have scheduled 18,200 of. So then I can do like matchups is going to be equal to schedules, left join optimal scores, select franchise ID. So these are characters. So that, okay, so that's going to be annoying. Not annoying, slightly annoying. Franchise ID equals as integer franchise ID, and franchise name I can just take optimal. N is going to be the same as season, so season equals N. Optimal score. This is just a mutate. I really just want to bring all of it, I think. All play wins can stay. All play wins equals all play percentage is going to be equal to all all play wins divided by n minus 1, n minus 1, minus 1. I'll spare 10 seconds to do that while I think about the team's gonna be equal to franchise ID, so team's okay. And then opponents doesn't matter. Okay, so I'm gonna do that, and this will be by equals C, team equals franchise ID, left join, optimal scores mutate, franchise ID equals as integer, franchise ID wait, n here is a straight integer, so it's gonna be row number. Group by no, yeah, it's just gonna be row number. So mutate n equals row number. No, it won't be row number. It'll be season week. Is that right? Hang on. This is week. So it'll be group by week. Group by week. Because there's 1,300 weeks, so I need to have a week number. What's the fastest way to get a week number? N's going to be equal to cumulative sum of week not equal to leg week. Yes? No. Ba-ba-ba-bum. I guess I could group by team, mutate n equals row number, unmutate, ungroup. And that'll give me 1,300, right? Yep. Okay. That's gonna be the easiest way. Alright. So, and then we will add n as a join key. And then we will do the same thing over here. And we're actually going to, for the opponent, we're only going to select optimal score, franchise ID, and that's all I want. By equals C, opponent equals franchise ID, N. Oh, what the heck, I'll also bring in the all play percentage. Nah, I'll just bring an N. Okay. Opponent score equals optimal score. Y is missing. Why is Y missing? Not missing. Okay, so now if optimal score is greater than opponent score, and that should really be team score. So team score is going to be equal to optimal score. Bing. Team doesn't exist. Franchise name. Opponent name equals franchise name. There. So it's going to look something like that. Where basically I play Donkey Kong here. Simon Belmont plays Kirby. Donkey Kong plays Pikachu. That lines up. Okay. And then week. And then we can do a result. So mutate result equals case when opponent team score greater than opponent score equals win, loss, tie, true, NA. Character. I'll just change the sign. Go. Alright, so get a bunch of results. And basically, so now I can count the number of seasons that each player or each franchise, and like calculate the number of wins, losses, total points, opponent points, all play scores and wins. So that's where the all play scores and wins would have come in handy. All play rename. There. So now with this data frame, I can do a sum total of all play wins, and compare that with the total of actual wins, I think. Yeah, not bad. Whew. Okay, so getting some good chunks, getting a good chunk of work done. So now I can generate basically a win-loss. Got an NA here. What happened here? Bowser had an NA score. That's weird. And Donkey Kong has an NA here as well? That's also odd. I'm confused by this. Why does Bowser have an A in his range of outcomes? Okay, we're just gonna rerun that. Hopefully, that helps. Ow. Okay, slightly better. Okay, I think that makes sense. Okay, so, just observing the change I made there. Okay, so you got matchups now, and then I can do season summaries. So season summaries is going to be equal to matchups, group by, season. It helps to have this open. Okay, so we're going to have group by, season, and franchise ID, team, franchise name. Actually, we'll just group by franchise name. Makes it easier on ourselves. And then we're gonna do summarize wins equals result equals W. Head-to-head wins is equal to sum results equals W. Loss, no. H2H win percentage is going to be equal to H2H wins divided by N, which is just number of weeks. And we'll compare that with the all play wins, which is going to be equal to sum result, sum of all play wins, and the head to all play percentage is going to be equal to this all play wins divided by N times 13 in this case. I'm just going to crash home a summary so I can do a plot, and we'll call it a day. Call it a night. Ungroup. Okay, so with that in mind, I now have a list of season summaries, which works mostly, and I can map the number of the all play win percentage. I can map the head-to-head win percentage now. So I will copy this plot chart because it should work. But instead, I will take the season summaries, I will map it against a group by franchise name, I will make a mean H2H win percentage, and that's going to be the H2H win percentage. Good enough. We're going to rearrange that by mean H2H win percent. And we'll do H2H win percentage on the x-axis and bin lines. season win percentage. Season win percentage. 1,100 simulated seasons. Go. And unhelpful. Nice. Wins might be better than win percentage, so let's go with wins. Cool. So the teams that are the highest ranked. This is an interesting plot. I think bin lines is hurting me. But basically what this is showing is kind of your range of outcomes for a given season. Basically, so this kind of gives you the range of outcomes for a given season, and what it's telling you is, okay, so this cluster of teams tends to win in a season, tends to win something in the order of 10 games. You know, Ice Climbers has a slight lead, but like these three teams are clustered pretty tightly together. You can see that their average result comes out like bang on. Then you've got Link kind of coming out in fourth, Mewtwo in fifth, Donkey Kong in sixth. Donkey Kong has a better mean result. Donkey Kong has a better median result, but quite a bit of a lower tail. I think is the interpretation here. Mewtwo has a lower median result but a higher mean result. So I guess there's a smaller tail, but that is affecting the number of wins here. But this is kind of like a cluster of middle group people. Then you've got Luigi, Pikachu, which is me, Ness, and then you kind of got the bottom feeder. So Simon Belmont's like lagging way behind. Then you've got Bowser, Dr. Mario, Ness, Pikachu, Luigi. All of these teams just redispersed actually, so it's really interesting that they're all down here. I actually like the bin lines better. So let's try that. I do like these better. I don't like that they're so separated. So let me see if I can figure out how to tie these together. Bins equals 30. Bin width equals point. Bin width equals 1. Run your league. Sure. Is it in MFL? I don't have anything handy for Sleeper yet, so if it's in MFL, I will happily run it. And it can't be mid-draft, so I can't run your mid-draft league, sorry. But otherwise, yeah, I'll run your league if you want. And I know Joe's asleep. 63321, sure. 2021, right? I'm assuming. CMC 3 weeks ago. Yeah, so one of the really cool things is you could theoretically with this package, not necessarily with my code, not with the code I've got built, but we'll see how many things break. That's a great test, but I think that should work. Nothing. I think I thought of as many things as I could think of. Evaluate trades with this. Yeah, if you could evaluate trades, 14 leagues, that's fine. This is only going to show you like best ball, so there's going to be like some fuzzing that happens when I do like an algorithm for lineups, but on the whole, this is what your H2 like head-to-head stuff would look like. Mornings. Plot. Whoa. Okay, so I gotta clean this. Lol. I have a function for that though. Not function, I have code for that. Yes. It's actually in this page. Great. No, I fix it. It won't take me long. Um. Stringy. Library stringy. Slightly better? Wait, what? Why didn't it work? Hello? Decent summaries. Oh, and I don't have stringar, apparently. Actually, you know what it is? I don't have string remove all. That's what it is. Okay, hang on. Better. Okay, go. Alright. Ignore the... I can label it better, but actually, hang on. I can label it. If you want to fix... What's your league called? What's the best way to... What do I call your league? Actually, I'll figure it out. Hang on. It's a safe leagues. You're heavy water, so you're in 4th. But this still tell you, like, this tells you... Oh, hang on, and it's 14. How many weeks is your season? I think I hard-coded that. I don't think it matters, but... Actually, I don't... I can't actually... Well... Yeah, I don't think it matters. 13. Okay, perfect. Yeah, so this will be 100 seasons of your league. In 100 seasons, your redraft rank will somewhere between... so there will be bad seasons are... Hey, Stream Elements. How you doing? My bot decided to randomly kick in. That's low. When CNC doesn't play, you lose. I think that's a good way to state it. You're kind of... So this is 5, 6. So your median rank will be 7 wins out of 13. But there's a good tail here. Like, you've got a good chunk of seasons that you win 10 games. You probably won't win, like, 11 or 12. Like, there's, like, no odds here that you're gonna do that. But on the whole, you should win, like, between 7 and 10 games based on today's rankings and based on the simulation. And perfect lineups. Don't forget that too. Which is not bad. Like, that's a pretty good team, right? Like, coming in 4th like that's pretty good. Maverick, Expendables, and Sean Spencer are kind of leading the way. And hey, look, poop emoji turned up. Look at that. Wait. You've got an extra first to play with. Nice, yeah. I mean, being in this range means that, like, you're here, and so any one of these teams... You saw with Tony's... I don't know if you saw this with Tony's thing earlier, but this does happen at a decently large clip, that the number 1 team with 61% chance of being first still ends up in 3rd or 4th, right? Like, it is very possible that, like, there's going to be some kind of outlier magic that happens. And, you know, his team was projected to be 61% based on actual scores to be that. And so if he ends up over here, that's kind of crazy, but that's the way things worked out, right? So, 100 simulated seasons, your season wins somewhere like that. Hang on, I can either tweet this at you or DM it to you or something. Season wins. 13 game regular season. And scale X. Scale X. Or we'll go X lim. 0 to 13. There. Okay, I will drop this into There you go. Go nuts. Obviously, you know, all the usual caveats about it's in dev, but you are happy to share that with your league or wherever. Twitter's fine too. I don't care. That sounds good by me. But yeah, that's looking pretty awesome, I think. And so the goal here is to kind of get from not get from somewhere, but just kind of get into slightly more detailed stuff with okay, so I think I mostly have the schedule sorted out, which is what I wanted from this. I wasn't able to get Tony's package working. I don't think I need much more performance out of this, to be honest. I think the default's gonna be comfortably around that 1000 mark. It'll take 13 seconds to run, and I can do math on how many seasons, but the seasons aren't gonna add much overlay. The schedule won't add much overlay. It'll be mostly the potential points calculations, which I think is important just because I don't want to hard code that. So I think it's better to use the constraint programming, but there'll be some work in connecting all of these dots left, but this is pretty good, I think. So not bad. I am 47 minutes over my time, but it is Saturday night, so that I kind of figured I would let myself extend over that period a little bit if I wanted to. So thanks for tuning in. I have no idea who's still here, how many people are still here. I don't really care, but you know, it's nice to see how many people are here sometimes. Let's see. 6 whole people. Nice. Okay, so we're going to go find somebody to raid, and we'll close out the stream for tonight. Does anyone have any preferences while I start looking at people? And if not, this was always Eric. Glad you're here. Yeah, I solved the problem I wanted to solve, which is always good. Jarek, how you doing? Not sure if you're just tuning in or we've been here a bit, but welcome. Just wrapping up. Preferences, you've been here a little bit. Nice. Yeah, so I got to where I wanted to, which is good. And it's actually like a really good like a schedule generator. I think it's actually like really good. Yeah, I mean, totally chime in. That's awesome. You don't have to like, you know, say stuff or whatever, but I appreciate you being here. Okay. I think that schedule simulator is going to be really cool, actually. So, you know, if nothing else, you can use it if you generate your own simulations. So I think it's really useful. So, okay, so let's go find somebody. Hacking Saturdays, code help, lead code and chill, platformer. Let's try to find a programmer. Preparing to integrate some AI looks interesting. Yeah, let's go here. Okay, so we're gonna raid Territe. He seems to be streaming C# code, and I think it's a game development stream, so looks cool. We're gonna go there. thanks for coming in tonight, everybody, and we will see you all. I'm streaming again tomorrow at 1 p.m. Eastern. So thanks again. Take care.
So this is going to be cleanup. We might not. Hey! Thanks for the raid. You've caught me doing a little bit of code review. I am preparing to integrate my changes into this person's work. So I'm checking to see what they've been doing, to see if I can make sure any conflicts, if there are any, are nice and easy to fix. So sit down, strap in, enjoy some exciting code review content. I'm going to charge you for the whole seat, but you're only going to need the edge. Look at all these methods that don't need to be called anymore. Don't like spaces, that's okay. Get all possible moves. Why does that need promotions now? Defend. It needs promotions for defend. Okay. Makes sense. Index. Vatican valid. I think I did the same thing, but I have a uppercase I. I did something similar, but I have like get byte. I really need to get that out of my PR. Get all indices.